Hello, this is Santosh Shinde, Assistant Professor IT Department, PPKBIT Baramati. Here I am presenting a topic on projection, one of the important topic in computer graphics. Let's see the general definition. Basically, a projection is something that transforms points in n space to m space where m is less than n. In computer graphics, this was in general, we define it like this, that a projection transform points in n space to m space where m is less than n. In computer graphics, it maps 3D camera coordinates to 2D screen coordinates. For perspective transformations, no two rays are parallel to each other. So this is a perspective transformation where no two rays are parallel to each other. Like we are looking at the stars from a longer distance. We are looking at the moon from a longer distance. So everything converges to our eyes, and this is a realistic projection. So this is also called as perspective projections or perspective transformations where no two rays are parallel. Whereas if you stand in front of a mirror, that is an example of parallel projection. Okay, so this is a taxonomy of projections. Basically, we have two main types of projections. Parallel projections, as I just now said, that if you stand in front of a mirror and see your own image, so that is an example of a parallel projection. Whereas just now we could see some mountains, some longer distance objects, or any objects, even nearer distance objects, 3D objects, that is realistic, and it's a perspective projection. Perspective projection is again of three types. It is one point perspective projection, where the point of convergence, it is single point of convergence, 2-point perspective projections, and 3-point perspective projections. Now coming to parallel projections, there are two types, again major two types: orthographic projections and oblique projections. Orthographic projections, we can see the top view, the front view, the side view of objects, as you could have also learned in fundamentals of graphics in first year. And again, orthographic projections can be of the type axonometric. There are again subtypes like isometric, diametric, trimetrics, and others. Oblique projections can be cabinet projections, cavalier projections, depending upon the value of the angle, and others. So this is the overall taxonomy of the classification of projections. So focusing first of all on the parallel projections. Parallel projections, the center of projection is at infinity, and the direction of projection DOP is same for all points since it is parallel in nature. So this is an example of a parallel projection. You take the parallel projection of front view of the house over here. So the direction of projection is same for all the points, and this is going to be a view plane, and this is the object whose projection we are taking. Orthographic projections like front view, top view, side view, we can take different views of this 3D object. So that is an example of orthographic projection. The direction of projection is not perpendicular to the view plane. Such a projections, we call them as oblique projections. And again, there are of two types. Either they can be cavalier projections or cabinet projections, where the direction of projection angle alpha is 45 degrees. If the value of the angle alpha is 45 degrees, then we say it is a cavalier projection, and if the value of alpha is 63.4 degrees, then we call it as cabinet projection. Parallel projection view plane. So this is the front plane, this is the back plane, this is the parallel piped view volume, and this is the actual window, and this is of course the Z axis. Parallel projection matrix, we have already derived this matrix, so this is the matrix that we have already derived. Coming to the concept of perspective projections now. Map points onto view plane along projectors emanating from center of projection. So the center of projection is your eye over here, and there are the projectors. This is used, perspective projection is basically used for realistic representations of objects. How many vanishing points? Depending on that, again there are subtypes like 3-point perspective projection. So here the number of vanishing points are 3, here there are 2 and 1 respectively. So we have 3-point perspective, 2-point perspective, and 1-point perspective projections. The difference is how many of the three principal directions are parallel, or you may say orthogonal to the projection plane. Perspective projection view volume, if you see the projection reference point, this is the point of convergence. This is the window, which is the view plane. We can see the front plane, back plane, and the frustum view plane. Camera to screen, the object is captured through camera, so 3D to 2D, kind of conversion, and then is represented on the screen, just like a ray tracer. We would skip these mathematical parts which we have already derived. We have derived this. Going to the conceptual part of it, the perspective matrix also we had derived it. It is a 4x4 matrix, and all the diagonal values you can see, first three are 1 and the last one is 0, and just before that we have 1 upon d. What point is this in non-homogeneous coordinates? These are non-homogeneous representation of coordinates. Okay, coming to perspective versus parallel projection, the difference between the two, conceptually speaking. Perspective projection is shown here. You can see the diagram. Diagrammatically it is shown. Its size varies inversely with the distance. It looks more realistic. So as the object goes farther away from us, its size reduces, and the object comes closer to us, the size increases. So that is proportional. The size is proportional, inversely proportional with the distance. As the distance increases, the size reduces, and as the distance decreases, the size increases. So nearer object looks more larger in size, and farther objects looks more smaller in size. So that is more realistic. It looks more realistic. The distance and angles are not in general preserved in perspective projection. Parallel lines do not remain parallel in general, whereas in parallel projection, diagrammatically again it is shown here for more conceptual clearance. Good for exact measurements. They're good for exact measurements, for some scientific and engineering measurements, for some design applications. In mechanical engineering, more into civil engineering, parallel lines remain parallel here. Angles are not in general preserved, and they are less realistic looking as compared to perspective projections. So classical projections, we have front elevation, then we have isometric projections, we have elevation oblique, we have 1-point perspective, plane oblique, 3-point perspective. These are some figures we have. Thank you.